STEM and design application. Application of design thinking in education. Preparing young people for a future of complex challenges such as globalization, digitalization, or climate change requires high-quality STEM education. Additionally, skills such as creative problem solving, the ability to innovate, and critical thinking are increasingly important for openly embracing change and conscientiously shaping the future. It is necessary to emphasize the importance of understanding the concept of design thinking. Teachers can apply the concept of design thinking as a teaching method in their lectures. This section shows how to approach teaching some topics. Teachers can easily adapt their lessons according to this template. Not all steps are worked out in detail. By knowing the domain knowledge of each lesson, teachers will better elaborate each of the 5 steps. Case study: rising energy prices, household consumption, and renewable energy sources. Present to the students the problem of the increase in energy prices and the amount of energy consumption. Also, present them the problem of environmental pollution. Encourage them to think about possible alternatives. One of the possible scenarios. Empathize. During this stage, students are trying to understand the problem they want to solve. They need to understand the problem of energy production, energy consumption, charging for the use of energy sources, energy loss, environmental impact. They observe how it affects people's lives and they empathize with them. Phase 2. Define. Students analyze the information and define the main problem. Ideate. Students must be creative. They must investigate all causes of the problem. They reflect on the negative aspects of current approaches in order to design new approaches. Using current knowledge in physics, mathematics, biology, geography, and chemistry, they brainstorm new ideas and possible solutions. Prototype. They make mind maps, posters, sketches, and diagrams to show possible solutions. Test. Students need to question every aspect of their prototype. They have to ask themselves, did they consider every point of potential pitfalls of the solution they thought of? If something seems badly executed or designed, it is necessary to return to the previous stage. Teachers should encourage students to present in front of a class. It is necessary for students to be able to explain what they did and why. Also, teachers must be available to students throughout the process in a way that guides them, not solves for them. This concept teaches students to work in a team and encourages them to take initiative and responsibility. Conclusions. It is important to explain to students that design thinking is not a linear process. Some insights may lead to retracing previous steps and modifying some of the conclusions. All of the above are just guidelines, and the stages do not have to be consecutive or follow a specific order. They can take place in parallel, but also repeat and overlap. This is exactly the basis of this iterative process that we call design thinking, that can lead to expected and unexpected insights that can lead us down a new path. Last stage, the process is not finished, but returns to the starting point, and the product or process in question is improved through the process of iteration. Each of the mentioned phases can consist of different processes, methodologies, and tools, depending on the need and the progress of the project. This is the reason why we cannot place design thinking in strict frameworks and define it step by step, because every problem is unique and must be approached in an individual way. However, the mentioned frameworks and processes always exist, only their structure can differ. Considering all of the above, we can conclude that design thinking includes the generation of new ideas for the purpose of improving the experiences and lives of other people, ourselves, and the environment and society around us.